One type of motion that's very important to us that we are going to discuss is what we call free fall. Okay, what do we find as free fall? Is when the only force acting on the object is gravity. Okay, the rope here is broken, nothing else but gravity. That's when we call it free fall. It does not matter if the object is going up or down, as long as the key is the first item. The only force acting on the object is gravity. If that's the only force, we call that free fall. Let's remember our equations for motion at constant acceleration. Remember, we said if the acceleration is constant, we don't really talk of an average acceleration. It's just A. The position is given by, let's say, along the x, xf is equal to xi plus vxit plus 1/2 of ax t squared. The velocity is vx plus axt. This is a general displacement equation. xf minus xi is average velocity times time. And then this nifty equation, vf squared minus vi squared is equal to a times d, times displacement, which is xf minus xi. We can use that equation when we don't know the time. Now, one thing that we said about free fall, that we mentioned, the key is the only force is the gravitational force. Another thing that we need to remember is Newton's laws of motion when we talk of force. Remember Newton's second law of motion, we mentioned it earlier when we talked about acceleration. It says the sum of all external forces, or the net force, is equal to the mass times the acceleration. The net force, or sum of all external forces, is ma. In this case, the only external force is the gravitational force. That's the only force, the gravitational force. That's important. Now, let's discuss a few things here. First, what's the difference between mass and weight? Mass is a measure of how much an object resists being accelerated. It is the amount of matter. The mass is not going to depend on where an object is. The mass of an object is the same at the surface of the Earth, or on the Moon, or on Mars. The mass is the same. The weight, though, is a term that we use. The term weight is a term that we use for the force of gravity on an object at the surface of the Earth. Now, that's a special term that we use for the gravitational force on an object when it is at the surface of the Earth. Now, in other words, weight and force of gravity are synonyms. Now, the force of gravity, it depends on the mass of the object. The greater the mass, the larger the gravitational pull. Now, be careful about the use of terms. We talk of gravitational force or gravitational pull. The word gravity by itself is not going to mean much to us. So we have gravitational force. The gravitational force at the surface of the Earth, we call it weight. Okay, when an object is in free fall, the net force, like we just mentioned a minute ago, is the mass times the acceleration. But the net force is just that one force, the gravitational force, that we call also the weight. So these are synonyms. Now, the gravitational force is given by the mass times a certain constant. Okay, be careful with this constant. It is not gravity. What this constant is, gravitational field value. You notice it is a vector. It's going to depend on the position. At the surface of the Earth, the magnitude of G at sea level, at the surface of the Earth, it's about 9.8. Now look at the unit I'm going to use. Newton per kilogram. That's the magnitude. If we go further away from the surface of the Earth, it's going to become a little less. We'll talk about G a little later. Now, if you check the dimensions, newtons per kilogram, and it's not really our topic right now, comes out to be equal or equivalent to meters per second squared. So that's what we are going to use for a little while here, since we are talking of kinematics, but we'll go back to newtons per kilogram later on. So, to recapitulate, the force of gravity on an object, the gravitational force, which is the weight, is equal m times g. Since it's the only force acting on the object, our net force is just F times g. Which, if we go back to this first equation here, it tells us that ma becomes equal to mg, which tells us that the acceleration of our object is equal to the gravitational field vector. So A is equal to g. That's when an object is in free fall.